All right, so thank you guys for coming. I am glad that there are two of you. I'm always glad whenever anybody shows up, so always a good thing. I am going over basic percent problems. So these are problems where you're solving with percents, and this is actually the most common type of algebra that you'll use in your life, even if you don't realize you're doing algebra. So first off, I just want to go over the problem solving procedure, because if you have word problems, this is the procedure you want to go through. And even if you don't have word problems, this is a good procedure to follow when you're trying to solve problems. So the first step is to make sure you read the problem carefully. If it's a word problem, you might have to draw pictures, you might have to write down the information that you're given. If it's not a word problem, you need to actually just make sure you understand the directions. You know, if it says solve, simplify, that sort of thing. Step 2 is to assign a variable to represent your unknown value, or if there's more than one unknown, you use multiple variables. That's necessary for word problems because they don't normally tell you what variable to use. But if it's not a word problem, you can skip this step. Then you write an equation, or two equations sometimes more than that. Again, if it's not a word problem, this is already done for you. You're given an equation. Otherwise, if it's a word problem, you have to come up with it. And so that's part of the problem solving, is trying to come up with the correct equation. And you do that based off of your reading of the problem and the variables you picked. Then you solve the equation that you have. After you've solved, you should check your answer. So if all you have is an equation, you just check your answer back in the original equation. If it's a word problem, you want to, in addition to making sure that it works, you want to make sure that the answer makes sense. You know, it wouldn't make sense to have an equation where you're solving for time and you got a negative number, because we don't have negative time. So you want to make sure that the answer makes sense, that it's reasonable. So if you are trying to find out how many gallons you need to mix with 10 gallons of it, like let's say you're mixing water with some acid like hydrochloric acid, and you want to make, I don't know, like 10 liters of it. If you were trying to find out how much water you need to add and you got an answer of like 100, that wouldn't make sense because all you need is 10 liters. So if your answer is 100 liters, that's way too much. So you need to make sure that it also is reasonable. It's not way out of bounds. And then when you're done, you state the answer to the problem. So if for a word problem, this should be in a sentence in context so that you're fully answering the question asked. If it's not a word problem, this just means giving the answer. So this is the problem solving procedure. It's the same procedure used when solving. It's just when you have word problems, you have more steps, essentially. So we're focusing on basic percent problems. And so this is the one that I mentioned you see the most often. This is based off of the definition of a percentage. So the word percent literally is coming from two words. The word per means divide, and cent means 100. We have 100 cents in a dollar. Centurions were in a group of 100 soldiers. A century has 100 years. So this actually comes from the Latin word centum. So it means 100. So percent literally means you're dividing by 100. And so that is the most basic definition. And if you have a number and you want to convert it to a number, to a decimal, you divide it by 100. So we solve these problems in two different ways. We've got the first way, where you have to take whatever percent you got, you have to turn it into its decimal form, which means divided by 100, and then you put it in this formula, amount equals percent times base. And the base is like your starting amount, or you know, like what you're finding the percent of. And I will say of, if you see the word of, that means multiplication. So when you're translating something like this, we've got percent times the base, and that's because you'll see percent of something, and that's telling you to multiply. The second way to solve these types of problems is to write a proportion. And when you use this method, you don't need to convert it to a decimal because the formula does it for you already, because it already has dividing by 100 in your formula. So we're going to go through both methods, so that way you can see each one in action and you can decide which one you prefer. And sometimes maybe you use one method in one type of problem and the other method in another. You could use both methods, but I want to make sure that you see how each method is done, so that way you can choose the one that makes sense to you and that you are able to follow. So there's only a certain number of ways to write a percent problem. There's basically 3 different ways to write it because you have 3 different places where you can put your unknown. So this first one we have 338 is what percent of 520? So if we use way 1, we're using the amount equals percent times base, and that comes directly from translating our sentence or our question into math. Because the word is gives you an equal sign. The word of is multiplication. So if you were to translate this directly, you just go left to right. 338 is, and then the what is our unknown, our variable. And we've got of with its multiplication, and then 520. So this is the form of the amount equals your percent, which we don't know, times the base. So way 1 comes from taking that question that they give you and translating it directly into mathematics. So you have to be able to know that the word is always going to give you an equal sign. The of always means multiplication. And then the what part is your unknown, so that's where you stick your variable. And you can use X. You don't have to use X. You can use the letter P for percent if you want, whichever works for you. So if we solve by way 1, now remember, way 1 is always with the percent as a decimal. So whatever number you're going to get here, it's going to give you the decimal version of a percent. So to solve this equation, 338 equals P times 520, we have to divide both sides by 520 because I want to just find the percent. And with percent problems, we usually put it in decimal form. We don't have to worry about fractions. So when I divide, I get 0.65 equals P. Now this is the decimal form of the percent. And you get the decimal form by dividing by 100. So to put it back into the percent form, you have to multiply by 100. So multiplying that number by 100, that gives you 65% as your answer. So that's using way 1. We're using the formula, which is basically coming from the translation. You solve, and then you have to take whatever your percent was and multiply it by 100. Way 2, we have this part over the whole equals percent over 100. So I'm going to just rewrite this up here. The of is always the whole, and the is always the part. So if you're going to use the proportion method, you say, okay, what is the is? So we've got 338 is, so that's going to be the part that's going to be on top. The of is in the denominator, so it says of 520. So 520 is in the bottom. And then we are looking for the percent out of 100. So you can see that this looks almost exactly the same as what we had on the left when we started solving. It's like we already divided both sides by 520. What's different about this form is that we don't have to convert from the decimal to the percent because this will do it for us because we already have the 100 in there. So first, to solve this, I just need to do the 338 divided by 520. So that's going to be 0.65 equals P over 100. Whoops, I almost wrote 1,000. Then you multiply both sides by 100. And that will give us 65 equals P. And in this case, we don't need to convert it because it's already giving it to us in the correct form. So we got the same answer both ways. The method on the left, you have to remember to convert your decimal to a percent. The method on the right, you don't have to do that. So they get the same answer. It's just a method of which setup do you prefer and which one makes the most sense to you. Are there any questions? Okay, so here's another type of way of wording it, but now our what is in the is part. So there's three different ways to write these equations. So we have what is 9.5% of 616. So to write it like way one, you're just translating. The what is the unknown. We've got the word is. So that's the equal sign. Now you have 9.5%, so we have to convert that to a decimal by dividing that number by 100. So you have to write it as 0.095. Then we have the word of, and then 616. So in this case, this is really simple to do. We just need to multiply these numbers together to get our answer. We have 0.095 times 616 comes up 58.52. And we don't need to do any conversions to like multiply by 100 or anything because we're not looking for a percent. So we're just looking for the amount. We found the amount. So this is one where it's like one step essentially. To use the proportion method, I've got the is, which we don't know. The part over the whole, the of, is 616. And then that's equal to 9.5 over 100. So first, we do 9.5 divided by 100, which gives you 0.095. Then you multiply by 616 on both sides to get rid of that fraction. And you get x equals, and then we get the same answer, 58.52. So if I look at the previous example, this example where the unknown was the percent, I tend to solve this using way two. That's what I usually do to solve this, is I take the 338 divided by 520 and then multiply it by 100. For this type of problem, I tend to use way 1, where all I basically need to do is multiply as long as I convert it to the appropriate decimal. So I use both methods. It's just a matter of which method, I use. And one is quicker than the other. One seems to make more sense than the other. I just, choose the method based off of which seems to be quicker, basically, or which has the fewer mistakes. Are there any questions on this example? Okay, so this is the third type of problem that you can see. We've got 126 is 15% of what number? So using way 1, you've got 126 is, which is the equal sign, 15%. So I have to convert that to the decimal form. You divide it by 100, you get 0.15. And then of what number? And our what is now our unknown x. Now, if you are struggling to know how do I get my decimal forms, when you divide by 100, you move your decimal place to the left twice. So that's what I do to get my decimal form of a percent. You move it left twice. So like here, when I move it left twice, I have an extra 0 I have to put in. And that's how I got 0.095. Otherwise, you can just do it on your calculator and it will give you that number. So here we're solving for x, so we divide both sides by 0.15. And we get 126 divided by 0.15, 840. So our answer here is 840, and we don't need to convert it to a decimal because it's not a percent. And if you're wondering, oh, our problem solving method here, I wrote check your answer. Well, by doing it a second method, we're checking our answer. And then I have state your answer in a words, basically in sentence. These types of problems are not considered word problems here. Yes, they have words, but they're not really considered word problems. So you don't need to write your answers here in a sentence. We will do some word problems in a couple more examples. So if that just happened to cross your mind, these are technically not really word problems here. So way 2 is basically, I know I wrote part over the whole, but you can think of it as is over of equals percent over 100. So we have 126 is, so that's on top. And then we got 15%, so that's going to be also on top. And we got of what number, so the blank has to be where our variable is. So when I see a problem like this where my variable is in the denominator, instead of solving the way that we solved before where, I did a division, then I multiplied by the denominator, we can do that here, but we'd be multiplying by x. Instead, there is a technique called cross multiplying. And this only works if you have a fraction equals a fraction. So you multiply one fraction or one diagonal together, so 15 times x. And then it equals multiplying the other diagonal together, 126 times 100. So cross multiply, it means if you have two fractions equal to each other, you multiply the diagonals and set them equal. So this gives us 15x equals 12,600. And then we are dividing both sides by 15. Make that actually look like a 5 to find x. And so you can verify that on your calculator. We get 840. So same answer. So we know that we did this, correctly. For this type of problem, I actually prefer to use the method on the right, even though it's longer. And the reason why I do that is I find it's less prone to mistakes. I see a lot of people trying to do the method on the left, but they put their numbers in the wrong spot, and then they get the wrong answer. So when something's worded like this, I typically recommend to use the method on the right, but you can use whichever of these two ways you want because you'll get the same answer. So are there any questions? Okay, so here's another one. We have what is 156% of 280? So if we use way 1, what is our unknown? Is the equal. Now the 156, if you make that a decimal and you move your decimal place, it's going to be in between the 1 and the 5. So it would be 1.56. If you don't like the idea of having to move your decimal, divide by 100, what you could do instead is just remember to write your percent as over 100. So instead of converting it to the decimal form, you could make a habit of always writing your percent over 100, and then you don't really have to, remember, okay, put it in decimal form. Then we've got of 280. So if you do it this way, you do have to, I'm just writing it differently. You're going to get the same answer. You just have to do the 156 divided by 100 first, which is the 1.56 that I mentioned before. So, if you don't like the idea of dividing in your head, you can literally write it here. So you do 156 times 280, you get 436.8. And you do want your number to be larger. So 156% means you have more than 100%. So your answer is going to be bigger than the original 280. So that makes sense. Just to check ourselves with the other method, we've got is over of, so the what is the is, over the of, which is 280, equals our percent over 100. So previously when I showed this type of problem, I first did 156 divided by 100 and then multiplied both sides by 280. But if you want, you can do cross multiplication. You can multiply your diagonal and do the 280 times 156 equals the other diagonal, 100 times x. So you could do it that way. So 280 times 156, 43680 equals 100x. Then you can divide both sides by 100. And we got 436.8 equals x. So we get the same answer. So what I hope you're getting out of this is that there are lots of different ways that you can solve these equations and get the correct answer. And so it really is about figuring out what method works for you, which method you find helps you get the right answer the most times, or every time ideally. Are there any questions? Okay, so here let's get into some of the word problems. So these are the ones where you have to pick your variables. You're going to have to go through the whole problem solving process. So I'll help walk us through. Patrick purchased 4 new tires that were regularly priced at $94.99 each, but are on sale for $20 off per tire. If the sales tax rate is 6%, how much will be charged to Patrick's Visa card? So after I read through the problem, I like to make notes. So we have 4 tires at $94.99 each. Maybe I should write per tire. They're on sale for $20 off per tire. So I can just write minus because we're subtracting $20 off per tire. So as you're making notes, you can do that subtraction and say, okay, so it's going to be $74.99 per tire. So we've got the sales tax rate is 6%. How much will be charged to his Visa card? So the total is always going to be whatever the purchase was plus tax. So we're just going to keep that in mind. So we know that we've got 4 tires at $74.99. So our total purchase is going to be 4 times $74.99. So instead of using variables, I'm just writing in words because that makes sense to me. Like I can look at that and understand what I'm doing. So I'm just going to do that math. So the total cost of these tires is going to be $299.96. So now I need to find out how much tax is. So tax is 6% of the cost. If you say that out loud, tax is 6% of the cost. That is now put it in the form of those sentences that we were just looking at, where you've got the is, you've got your tax equals 6% of the cost. So you can take what you're doing, write it as a sentence, and then use way 1, where you translate it directly. The other way is to think about it as the part over the whole equals your percent over 100. And if you do it that way, then you kind of think about, okay, we've got 6% out of 100. So the 6% is tax, and the whole thing is the purchase. So you can use method 2, or way 2, and use the proportion method, where you just kind of replace the part and the whole with the things that you're looking at. The tax is 6%, so that has to be across from each other. And then your purchase, you're paying 100% essentially, so that's across from there. So I'm going to give you guys the choice. Do you want to use method 1 or method 2? So you can just type in the number in the chat, and then I will do that method for solving. Okay, so I've got to vote for method 1. So if I use method 1, I'll do what we have on the left. So tax, I'm going to just use the letter T to stand for tax. So this is where you pick your variables. And so I'm going to just write over here, T is tax. So I've just kind of picked my variable. So tax is, so that's the equal sign, 6%. So we're going to divide by 100. It's going to be 0.06 of, and then the cost, and that's what we just found was 299.96. So I want to just multiply those together, and we get 17.996. So we have more decimals than we need. Money always has 2 decimal places, so we need to round this number. And so I'm going to round it after 2 decimal places. So I just kind of put a line, and you look at the number after that line. If it's 5 or higher, you round up. So that means that this 9 has to round up to a 10. So that becomes a 0, and then we have to carry the 1 from the 10. So 9 plus 1 also becomes a 0. That carries over, and this rounds up to $18. So when we round this to 2 decimal places, we get $18 for the amount of tax. So you want to be careful that you're actually, you're not just getting this number and saying you're done. You have to go back to what the question is asking for. So the question says, if the sales tax rate is 6%, how much will be charged to Patrick's Visa card? So we don't want just the amount of tax. We want the total, the amount of purchase plus tax. So we have to go back to that equation that I wrote, that your total is your purchase plus the tax that's added on. So our total is 299.96, plus the $18. And that gives us 317.96. And now this is a word problem, so we write our answer as a sentence, and we would say, and you kind of repeat back the question. So we would say $317.96 will be charged to Patrick's Visa card. So basically, I took that last sentence that said how much will be charged to Patrick's Visa card, and I just kind of repeated that, but I put in my answer. And that's how we do problem solving on a word problem involving percents. So you take what you know, you write your relationships, how you know things are related. You do some arithmetic, you have to throw in some algebra, but then that gets you your answer, and then you repeat it back as a sentence to confirm that you are answering the question that was asked. Are there any questions? Okay, so here's one where we've given a pie chart. So pie charts always demonstrate percents, and the whole circle is 100%, and then it divides it up into different sections. And so if you added up all those percents, they would equal 100%. So this chart is giving us the percent of cancer cases by type, and this is specifically just for men. And so We have a question. Approximately how many cases of lung cancer would be expected in 700,000 cancer cases among men in the United States? So if the total number of cancer cases is 700,000, how many will be lung cancer? So this type of problem is one that I tend to set up using the second method because that's the part over the whole. And this kind of problem gives me the whole pretty clearly. We have a total of 700,000. So that's the whole thing. That's the total. So I solve this using method 2. So the part over the whole, or if you don't like the word whole, you can put total, is percent over 100. So we know, I can kind of set up my fractions, that there are 700,000 total cases. And so we want lung cancer, and if you look for that piece of the pie, it's 13%. So I'm going to put 13 up there, which means my unknown is in the remaining spot. So I'm going to solve this by cross multiplying, just because that's just the method I tend to do. So I'm going to multiply the diagonals, and it doesn't matter which diagonal you do first. I just always tend to do that one. So I'm going to be multiplying 13 by 700,000, and then that's going to equal 100x. So I am going to get some pretty big numbers here. And if you are kind of savvy, like if you kind of understand what's going on here, what we can do is divide by 100 before we actually even do the math. So when you do that, you basically get x is going to be 13 times the 700,000, and then we're dividing by 100. Or if you want, you can actually use the division symbol. And you just do that left to right in your calculator. And so you can kind of do it in one step. 13 times 700,000 divided by 100. And that will give you 91,000. And so luckily this is a whole number. If this was like a decimal, we'd have to round to a whole number because you can't have a fraction of a case of lung cancer. You either have it or you don't. You don't have like half lung cancer. But we've got a whole number here, so we would just kind of repeat back the sentence and say, out of 700,000 cancer cases among men, in the, I'm just going to abbreviate, US, 91,000 are expected to be lung cancer. And that would be how you would write your answer. As you write a sentence and you're given all of the important information so that if all they had was your final answer, they understand what your answer means. Because if all you gave someone was 91,000 and they didn't quite understand what the question was, it's not going to be enough information. You want to give your final answer for a word problem with all the information needed to understand what the answer means. And so that's why you basically repeat back the question. Are there any questions? Okay, so this is my last example, and I picked this one specifically because this is another instance where this is very related to real life. So we've got Javon is in a 28% tax bracket for his federal income tax. And I think that's like the most common tax bracket. I think it ranges from like 25K to like 120 or something like that. I could be wrong, but I know it's a pretty big tax bracket. If the amount of money that he paid for federal income tax was $23,520, what was his taxable income? So this is one that most people tend to do incorrectly, which is why I'm also doing this one. So we have to figure out, how do we set this up? We know we've got a percent, so we got to think about what we know. So we know that our percent, which is the tax, is 28. That's the tax bracket. And we know the total tax that was paid was $23,520, and we want to know what was the total income. So the income is the amount basically before you removed tax. So it's the whole thing, and then you paid some amount of that to be taxed. So you can write this as a sentence. 28% of the income is tax. So we can do this to write our equation. So if we're going to do the translation, use way 1, that would be 0.28 of the income is what we don't know. And I don't recommend, if you're going to, don't use a lowercase I, you might want to use an uppercase I so it doesn't look like a 1. I like to use the letters. That kind of makes sense. So if we want to know the taxable income, we can use I for income. The word is the equal sign, and then we've got tax, which is 23,520. So if you just rephrase what is actually going on, you can get your equation and plug in your numbers. Alternatively, if you want to do it as the proportion method, we'd have the 28 over 100. Your total is going to be your unknown income. That's the whole thing. And so that then tells you that the top needs to be your 23,520. Because you know the whole income, it's got to be bigger. That's going to go on the bottom. But if we use way 1, I've got 0.28 I equals 23,520. And so to solve this, we divide both sides by 0.28. A lot of people tend to multiply, and that's why they get this problem wrong, because they don't have it set up right. We're dividing. You should get a number bigger than where you were. So this will give us 84,000 as your answer when you do the math. So his taxable income was 84,000. He got charged for 28%. He paid out 23,520. So we found our answer. We just need to write this as a sentence. Javon's taxable income, taxable income was $84,000. So the question just says, what is his taxable income? So I don't have to throw in the 28% or the total amount paid for the income tax, because the question just says what was his taxable income. His taxable income was $48,000. I mean, $84,000. Apparently I'm dyslexic and reversed those. Are there any questions? Okay, so if there are no questions, that's all I've got for you guys, just to go over those types of problems. These are, used everywhere because you often deal with percents in real life, so at least now you have an idea of where you're doing algebra and that you are doing algebra. And now you may have some more information that you can do some harder percent problems. So this week you are going to be looking at a lot of different types of word problems and practicing your solving that you learned last week on these types of problems. I do have in the classroom in the video section, there is a video called Types of Word Problems, and it goes through all the different types and how you set them up. So even if you don't watch the video, downloading that PowerPoint will be very helpful when you're going through the word problems, because it shows the setup for all the different types and how to kind of know which type each one falls into. So it's going to be a very helpful resource for you. So I recommend that you have that handy when you get to the word problems. And if you guys run into any issues throughout the week, of course, you can reach out to me. And I hope you guys have a great evening, and I will see you guys next week. So take care. Bye.